Hello everybody, how are you? Hope you are all in good health. Today myself Piraj Mojumdar again welcomes you to the casting sequence. Previously we have completed the introductory part of casting as well as the sand mold preparation and the patterns also. Today we are going to have some more interesting topics on casting as well, and we are having molding materials, molding sand composition, testing sand properties and mold sand properties. And apart from these topics also we will discuss about some machines used for molding purposes as well as for sand making purposes also. Okay, so stick to this video till the end and we will learn a lot. Okay, now coming to this molding materials, we already know in molding we have to prepare sand for casting purposes. Now for preparing the sand, that is a mold you can say, where we will be able to pour the molten metal, we have to check some of the properties of the molding materials, or you can say the properties of the sand, mold sand you can say. Okay, now coming to the properties, first one is very important, that is I already discussed also, but still I will be telling you a bit on the refractoriness. You already know what is refractoriness. It is one of the most important property of the molding sand. Okay, now refractoriness, as I earlier mentioned you, it is the ability, you can write somewhere. Okay, it is the ability or you can write it is the ability of the molding material as well to withstand the high temperatures of molten metal as well. Okay, so from here you can see we generally use sand as refractory material in molding or you can say in casting, and as sand has got its high refractoriness. Okay, so now I will give you some data on refractoriness of different materials. You can see over here, silicon is the most commonly used refractory material for molding purposes. Now you can see the right hand side shows the melting point. So the more the value of the melting point, the more refractory the material will be. Okay, so you can see silica SiO2 have 1710 degrees Celsius is the melting point. Okay, now coming to the alumina Al2O3, it has got 2020 degrees Celsius. For magnesia MgO, it is having 2800 degrees Celsius. Thoria THO2 gives you 3050 degrees Celsius. Zirconia gives you 2700 degrees Celsius. And the melting point of graphite, you can see over here, is 4200 degrees Celsius. And for silicon carbide, it is also one of the hardest material. You can see SiC, the symbol is given over here as, and the melting point is 2700 degrees Celsius. So you can see these are the values of some of the well-known refractory materials for molding purposes. But the most common one we generally use in casting as refractory material is silicon oxide, that is silica. The next most important property of molding material is green strength. Now you must be wondering why it is named as green. Strength you already know, strength of the molding sand or molding material, you can say the strength is playing a vital role in holding the sand together. So you know strength, but you don't know, or you are wondering why it is known as green strength. Look, the molding sand that contains moisture is known as green moisture. Okay, so as it is containing moisture, molding sand, it is known as green. Okay, and green sand you can say also. Okay, and the green sand is that sand which contains moisture, you can say. Okay, now the green sand should have enough strength so that the constructed mold retains in shape. Okay, next is your dry strength. Look, dry means when it is not containing any moisture. You can, from the name you can suggest it is dry, why it is dry. So when the moisture in the molding sand is completely expelled, moisture, you can write, moisture is expelled. Okay, then it is called dry sand. Okay, so it is called dry sand when there is no moisture. So how to perform that? You have to keep the moisture containing sand, or you can say the green sand, in a core baking oven. You can take a note on core baking oven. They are generally found in mechanical workshop. They are very common. Core baking furnace, you can write. Okay, core baking furnace. So in core baking furnace, what we do actually, we make a sample of the moisture containing sand, that is the green sand. So we have to put the green sand in this particular core baking furnace, and we have to apply high temperature, and we have to keep for some time as well. After keeping some time, the moisture will be expelled out of the green sand, and the remaining sand is known as the dry sand, where there is no moisture. Okay, so it is now very clear to you what is the difference between a moisture containing sand or the green sand and dry sand as well. Okay, now previously we learned the green strength, that is the strength of the moisture containing sand, that is the strength of the green sand. So green strength is for green sand. Now dry strength is for dry sand as well. Okay, and when molten metal is poured into a mold, the sand around the mold cavity is quickly converted into dry sand. You can easily assume that when we are pouring the molten metal, due to its high temperature, the moisture will be expelled out of the molding sand, that is the green sand. So it will be converted to dry sand as well. And at this stage, it should retain the mold cavity and at the same time withstand the metallostatic forces. So this is very important, that dry strength. Okay. Next one is your hot strength. No, look, after all the moisture is eliminated, the sand would reach a high temperature when the metal in the mold is still in the liquid state. The strength of the sand that is required to hold the shape of the mold cavity at that time is known as hot strength. Look, next one is your permeability. Look, I already mentioned the usefulness of permeability during casting process, as because due to high temperature, there will be gases produced out of the mold cavity, and you need to provide safe passage for the gases as well, for their easy escape out of the molding cavity, you can say. Okay, now if that particular molding sand doesn't have enough permeability to permit, what is permeability? That is the ability to permit the escape of gases from the molding sand. Now if the particular molding material doesn't provide space for the escape of the molding escape of the gases produced out of during casting process, then there will be casting defects as well. So you have to keep in mind whether the molding material, that is the molding sand as well, does have permeability, a good permeability or not. Okay, so during the solidification of a casting, you can write it as during the solidification of casting, large amount of gases are to be expelled from the mold. The gases are those which have been absorbed by the metal in the furnace, air absorbed from the atmosphere, and steam and other gases generated by the molding and core sands. Now if these gases are not allowed to escape from the mold, they would be trapped inside the casting and will cause casting defects. The molding sand therefore should be sufficiently porous. Molding sand, you can write, permeability is very important. Molding sand should be sufficiently porous. Okay, that is having intermolecular space to provide escape route for the gases, that is porous. Okay, so that the gases are allowed to escape from the mold. The gas evolution capability of the molding sand is called as permeability. Okay. Now, these are the main properties of the molding materials. And beside these properties, the molding sand should also have, you can write it as collapsibility, and so that during the contraction of the solidified casting, it does not provide any resistance. Collapsibility, okay, it is a property which may result in cracks in these castings. Okay, so it should have also collapsibility, and they should be reusable and should have good thermal conductivity as well, so that heat from the casting is quickly transferred. Okay, now let us come to the next topic of molding sand composition. This is very important for your semester examinations, for MCQ purposes as well. Okay, in competitive examinations they are going to ask you the principal compositions of the molding sand as well as their percentages also. Okay, so in molding sand composition, first is your silica sand. As I already mentioned you, SiO2 silica sand is commonly used as molding material in casting purposes, as because silica sand have got a enough melting point, that is around say 2000 degrees Celsius, and if we are doing iron casting, the melting point is around 1739 degrees Celsius. Okay, so 1539, that should be 1539 degrees Celsius melting point. It also varies somewhat, but it is recommended in many books that the melting point of iron is around 1539 degrees Celsius. So if we are using silica sand as refractory material for molding purpose, then we are having this silica sand having around 2000 degree Celsius as melting point. So we are safe in using silica sand, and it will hold the temperature, high temperature of molten metal of iron. Okay, now one more thing is there about using of silica sand, as there are many other sand as well, other material, refractory material as well, but we are using silica sand. Why we are using silica sand? There are also other materials which are much more higher refractory values. Okay, as you have already seen, there is zirconia, thoria. There are also many other refractory materials are there, but silica sand is easily available from riverside, you can see, and it is cheaper also, that is inexpensive. So we are using mainly silica sand for refractory materials. Now coming to the silica sand, we have to determine, or you have to memorize the percentages as well. Okay, now the sand which forms the major portion of the molding sand, up to 96%, you can say, okay, up to 96% is essentially silica grains. The rest others being the oxides, such as known as alumina, you already know alumina, and sodium also, okay, and magnesium oxide also. So they are also present in little amount, but mainly is the silica sand. That is the main composition of the molding sand. Okay, and you should keep in mind that silica sand, and you need not go in depth of these particular compositions as well. This is the main thing, that is the silica sand having 96% as well. Okay, and the source you already know. You all know where from we are getting the sand. Sand is we are getting from the river sand. Okay, the main source you can say is the river sand, which is used with or without washing. Okay, and now the shape of the grains, that is very important also. I will discuss somewhat later the shape of the grains. Look, we are getting silica sand from the river beds, and the shape are not alike. All the silica sands, the shape of all of the silica sands are not alike, but the shape of the grains, this is very specific type, very depthful concept. The shape of the grains may be round, subangular, angular, and very angular, and this size and shapes of these grains greatly affect the properties of the molding sands as well. You need not to know this right now, but this is very useful for different purposes we will be discussing later on, and in your lab also the teachers will be discussing with you. The shape of the grains is very important, playing a vital role in molding sands, in the properties of the molding sand. Okay, now one or two things I would like to again discuss with you about this silica sand. Look, we have already discussed the zircon sand, GRO2, zircon sand, you can say. Okay, the zircon, it is very expensive, so we are not going to use it. Generally they are used in some special purposes that I want to share with you, as because it is very important for your, maybe they are going to ask you any competitive examinations as well. Okay, and one more thing I would like to tell you that this zircon sand, that is basically known as zirconium silicate, JrSiO4, zirconium silicate, and the composition is GRO2 as well. So you need not know these things in depth. Just know one thing I would like to share with you, that is it is available mainly in the Quilon beach of Kerala. It is also not readily available, and it has fusion point of a very high temperature, 2400 degrees Celsius, and also a low coefficient of thermal expansion as well. Okay, and the other advantages are as well high thermal conductivity, high chilling power, high density as well. Now generally where it is used, that is a very important, I want to mention it for your competitive examinations. Generally this type of sands are used to manufacture precision, you can take a note somewhere, precision steel casting. That is a very important, you have to keep in mind about this zircon. Okay, precision steel castings, and that requiring better surface finish, and for precision investment casting we will discuss in later classes. That is the special type of casting. Okay, investment casting. Okay, so you must take a note these 2 points for this particular GRO2, the zircon sand. They are going to use in special type of castings where we are needing precision type and very good surface finish. So that is the precision steel casting and precision investment castings. Now one more sand is there, that is also very important for your competitive purposes. I will tell you, that is the chromite sand, Cr2O3 actually, chromite sand, and you can write it as Cr2O3, and fusion point is around 1800 degrees Celsius, and it is also used to this is a special type of sand, you can say, and it is also used for special type of casting as well, and it is generally used to manufacture, that you should take a note, to manufacture heavy steel castings, and with, you can say, better surface finish. Okay, better surface finish. So you can see, the more expensive the sand is, the better surface finish will be. Okay, and it is also best suited for austenitic manganese steel castings as well. Okay, so this is all about the molding sand. The first property we have discussed, the first ingredient, you can say, that is the silica sand. Now first most important or principal ingredient was the silica sand, and the second most important, or the second ingredient of the molding sand composition is, you also know this is the clay. Okay, and this clay are generally used with silica sand, and because of its clay are generally are known as for their binding agents. They are, you can write it as, they are good binding agents. So in addition to silica sand, we are also going to use clay for their good binding agents, which can hold the molding sand. Okay, and they are generally mixed with the molding sands to provide strength, and also because of their low cost and wider utility. Okay, and the most popular clay we are generally used are known as kaolinite. You must take a note, that is very important. They may be asking you questions or on which type of clay we are going to use generally in workshops and industrial purposes as well. Fire clay. It comes with formula as Al2O3 2SiO2, and it is also having a water component as 2H2O, and bentonite as well. There are two commonly used clay. One is kaolinite and another is bentonite. That is also Al2O3 4SiO2 and H2O there is also. Okay, so you can write in H2O. So the formula is not that very important, but you should keep a note of the main the clay we are going to use during molding materials. Okay, and also one thing you can take a note: kaolinite has a melting point of around 1750 to 1787 degrees Celsius as well, and bentonite is having a melting point. This is the melting point. Okay, so this is also melting point. For bentonite we are having 1250 to around 300 degrees Celsius as well. Okay, so this is very important, you must take a note. The commonly used clays are kaolinite and bentonite, and their melting point are as this, and that is all. Okay, so next one we will be having the principal among the principal ingredients of the molding sand. The next one is your third one is water, moisture. That is okay. So moisture is also very much useful in preparing molding sand during casting. Okay, now what is the purpose of moisture? Look, clay we already discussed the clay. Clay is activated by water so that it develops the necessary plasticity and strength. That's why we are using water. Okay, so it will make a good mixture of sand and clay. Water will help to bind the two clay and sand. So that's why we are using water to make a good paste. Not paste actually, the mixture actually. Okay, so the amount of water used should be properly controlled. That will cause if you are using above requisite amount of water, then the mixture will be somewhat look like paste. So we are not needing the paste, we are needing a solid but having collapsibility, permeability as well. So a proper amount of water should be needed to prepare a sound mold. Okay, now a part of the water should be absorbed by clay, and which helps in bonding, while the remaining amount of water helps in improving the plasticity, but more than that would decrease the strength and permeability. So you have to keep in mind, we have to add water in a requisite amount or a requisite percentage. Okay, so that percentage is very, very important. They are going to ask you in many of the competitive examinations. So you must take the amount or the proportion or the percentage of water we are going to use for a sound mold, that is around 2 to 8%. That is very important, very, very important. You should take a note. Okay, that is the moisture content of a sound mold. Beside these three ingredients we already discussed, the silica, sand, the clay and the water are the mainly molding sand compositions, the principal ingredients you can say also. Beside these main three ingredients, many other materials are also added to enhance the specific properties. For example, serial binder, they are also going to use. It helps to bind strongly the molding sand. Okay, and they are also using sawdust, cokes, okay, and sea coal, asphalt, fuel oil, graphite, molasses, iron oxide as well. Okay, so there are many more other things they are also going to use, but mainly three ingredients. That is, the first is your silica, second is your clay, and third is your water. These three are very important for your examination purposes. You should keep in mind these are the three main ingredients in molding sand composition. Okay, look, testing sand properties means the after preparing the molding sand, you have to prepare a small sample of the molding sand, say in this type of cylindrical shape, you have to prepare a sand sample. Okay, you have to ram it and you have to put in a beaker where you can ram it, so it will take the shape of the beaker, a small beaker, and you have to prepare a small size of sample. This you can say sample. Look, you cannot test the whole sand, so you have to make a sample out of the whole molding sand that you have prepared for molding purpose, for casting purposes as well. Now we have to run some, some tests, you can say. Okay, so for this testing purpose, whether this molding sand is having enough strength, enough durability, and all other properties, you have to run some test. Okay, and for this purpose, that is the known as testing sand properties as well. For this purpose, we have to perform some tests that is commonly known as, there are many tests. The main important test, I will write it here. This topic is very important for your lab examinations as well. Okay, in lab you have to perform these experiments as well. You have to carry out these experiments. Okay, now first, the most important one is your moisture content. So we have to test whether the moisture content of the particular sample, this sample is up to the mark or not. Okay, so in order to do that, I'm not going to the depth of this experiment. Okay, but I will just tell you the main motto behind this moisture content, and I can also tell you that in moisture content we are just using a experimental setup that is having calcium carbide. We are using calcium carbide to measure the moisture content. Okay, so I think that will be the most you should know that for theoretical purpose. Now when we will be performing this particular experiment in the workshop, you will be knowing the total, or the elaborative way of how to perform this experiment. For now only, you just know that we will be having a sample or experimental kit, you can say, and that will be that is known as also the moisture tailer, which will be having the calcium carbide, and with the help of that calcium carbide, a pressure will be created inside that chamber, and it will react with the water, as you know, calcium carbide and water, and it will produce a gas, and that gas will exert a pressure, and the pressure will be you can take the reading of the pressure outside of the say this is the experimental clip, and here will be the pressure gauge, and you will be able to take a reading of the pressure gauge outside of that particular experimental kit. From that particular reading, you will be able to determine from a given chart that what is the moisture content of that particular sample as well. Okay, now the second one is your clay content. We have to also run a test to find whether the clay content is up to the mark or not. Look, this is also experimental setup. We are having an experimental setup where we have to put the sand in a beaker. We have to stir it up with the water, and we have to we have to perform that experiment for some time. After some time, we'll be seeing that the clay content will be at the bottom of the beaker, from where we can find the clay content of that particular sample as well, right? Okay, now the third one, I'm not going to the depth, as because this is mainly highlighted for your lab purposes, but you should know what are the testing properties of a sand, what testing we have to done to check the properties of the molding sand. So I just telling you the overall view of the tests. I'm not going to the depth. Okay, now the third one is very important, that is known as the sand grain size. I already mentioned that sand grain size is also very important in determining the good quality of a molding sand as well. Now the sand grain size, there are different types of sand grain. We have a particular setup for this sand grain size. We are having a setup of we are having different pen. Okay, we are having generally a instrument, you will find in, you can see the picture in net as well, sheep shaker, that is it is very commonly used in workshops. Sheep shaker, sheep means the porous, the nets, you can see the nets, these are the sheep shakers. So it is the net, you can say. Okay, so it will be having different types of pens, which will be having different types of meshes as well. Mesh means how closely they are binded. Okay, So these are the types of different, pans of a sieve. The sieve shaker will be somehow a container, and where you have got different types of these are the known as the sheaves, you can say, where the meshes, which are somewhat closely fixed, where they are loosely fixed. Similarly, you have got a different, types of pans as well. Okay, from these pans you can, when when you are pouring the sand on the top portion, the top portion is having the most loosely attached sieves, and if you move toward the bottom of the sieve shaker, you will be finding the most compact or tightly fixed meshes of the sieves. Okay, so when you are pouring the molding sand top of the sieve shaker, and you are shaking, as we have seen in our household purposes as well, for the wheat, for shaking of the wheats. When they are shaking, this is a electrical device, so you need not have to shake in your manually, so it will automatically shake using electric current. When it will shake, the different the grains of the sand will come out, and it will fill up in the bottom as well. Okay, so with the help of the sieve shaker, you can determine the sand grain size as well. Okay, now the next one is very important, and it is important for your numerical purposes also. That is the permeability. You already know the permeability is the rate of air, or rate of flow, you can write rate of flow of air passing through a standard specimen. You can write under a standard pressure. Okay, standard pressure. So that is is the permeability. Okay, now this is very important, permeability, for your numerical purposes as well. Now look, there is a formula given over here that is known as P equal to V dot H by small p dot A dot T. Okay, now look, V, I can write it over here. So this V is volume, you can write volume of air. Okay, and H, capital H, is height of the sand specimen, height of the sand specimen, and small p is the air pressure, A is the cross sectional area, and the T is time in minutes, for the complete air to pass, to pass through, you can write. Okay, to pass through. So it is very important, the permeability. This permeability is also important for molding sand, and also for your examination purposes as well, as because they are going to ask you question on this particular, based on this particular formula as well. Okay, so you must take a note somewhere. This permeability is for a particular sand is given as or specimen, you can say. This permeability for a particular specimen, standard specimen, you can say, is given as V into H by P into A into T, and these are the nomenclatures of this particular formula. Okay, look, I forgot to mention you two more strength of the molding sand, that is the green compression strength and the green shear strength as well. Now look, green compression strength or simply green strength generally refers to the stress required to rupture the sand specimen. You can write sand specimen under compressive loading. From compression, you can say under compressive loading. Okay, so that is the green compressive strength. Okay, and That is all. Okay, now the range is very important. You must take a note somewhere. That is generally ranging of 130 to 160 kPa. So you must take a note. The green compression strength generally varies from 30 to 160 kPa for a good molding sand. Okay, now coming to the green shear strength, it is very important. Green shear strength is it is with a sand sample similar to the this test. Also we have to feed that sample in a machine known as universal machine that you can find very easily in generally any mechanical workshop. Universal machine, and you have to put that the sample in this particular universal machine, and you will be directly getting the green shear strength as well. Okay, now just you need to know the strength, the range of the strength that is mainly required for your examination purposes. Okay, and that is generally 10 to 50 kPa you can write, kilopascal. Okay, so these two things you must take a note. This is very important. So the range of the green compression strength for a sound mold varies from 30 to 160 kPa, and for the green shear strength it varies from 10 to 50 kPa. Okay, now you must also take a note of the previously I told you what is dry strength, and thus you just take a note for the range of the dry strength of a good molding sand, you can say. Okay, so it is around 140 to 1800 kPa. Okay, so these three things is very important. I forgot to mention earlier, so I have shared now with you. So you must take a note. The ranges are very important. Okay, so you must keep in mind. So for the dry strength it is 140 to 1800 kPa. Okay, now one more thing I think it is very important to share with you as well. I cannot show you the machine in this particular diagram, but I can tell you the name of that particular machine that is very important in mechanical workshop, in foundry shop you can also say. It is known as Mueller. So it is sand muller. It is very important machine. You must take a note somewhere. During the preparation of sand, you can write somewhere, during the preparation of sand, molding sand, when we are preparing molding sand, that is we are making binders, additives. Okay, so at that time we have to mix very well the sands with water, clay, and different other additives, binders as well. Okay, so in order to do that automatically with the help of electrical power, you can also see this type of, actually not this type of machine, but the constructions, civil engineers in the construction of roads, bridges, they are also using similar type of machine. They are mixing the concretes, okay, the cements, and we are mixing in sand muller the sand, the clay, the water, the binders, the additives as well. Okay, so sand muller is very important. You must know the name and the purpose of this particular machine as well. Okay, so you must keep in mind that sand muller is a very common instrument in foundry shop that is used for mixing of the sands for casting, or you can say for molding purpose as well. Okay, now as I told you earlier, the size or the shape of the sand grains that we are using in mixing or preparation of the molding sand, this generally the shape, or you can write the shape and size as well of this particular sand grains hugely affects the molding properties and the casting properties as well. Okay, look, the coarse grains, coarse means that is not finer. Okay, so the coarse grains would have more void spaces, that is void, this means they are having more void spaces, okay, between the grains you can also write. Okay, so these coarse grains are having more void spaces because they are irregular sized. Okay, not irregular, actually they are not finer. Also you can say the irregular also, and because of these more void spaces, you can see it will increase the permeability. So that is very important, the shape and size of the different sand grains. So it will increase permeability. Similarly, you can say for finer grains, it would have lower permeability as well. Okay, now these finer grains can provide better surface finish. That is the advantage of the finer grains. So you can write better surface finish for finer grains. Okay, now there are also widely distributed sand as well. Now the widely distributed sand would have higher permeability than the one with same fineness number, but where all the grains are of the same size. You can know. Okay, now the angular one, most important, you must take a note. There are also angular size grains as well, so you must take a note. Angular sand grains. Okay, now the angular sand grains, say this type of angular sand grains, okay, have higher amounts of binders. Okay, and this and the round grains means this type. The round grains would have lower permeability as because they are not having void spaces in between the grains. Okay, so you can write having lower permeability compared to angular grains. You can write also. Okay, because of the irregular shape of this particular angular grains. Okay, and coming to the grain size also affects the refractoriness. Higher the grain size, higher would be the refractoriness. Okay, and the purity of sand grains also improves the refractoriness. Okay, for example, say GFN. I didn't mention the full form of GFN. GFN is grain fineness number. That is GFN. Okay, grain fineness number. So sand grains of GFN of around say 30 to 45 may have a higher fusion point of around 1650 degrees Celsius. Okay, but finer grains, I already mentioned finer grains. The finer grains and impurities in the sand tend to lower the refractoriness by promoting fusion. So for higher refractoriness, you are going to use coarser grains, you can say. Okay, so you can say this is the all about the sand grains. Okay, look, some of the very important additives they are going to ask you in very competitive examinations as MCQs are very important, so I'd like to share with you. You must take a note somewhere else. Look, the additives we are going to use in apart from the main ingredients such as silica, sand, clay and moisture also. So I thought to share with you this mainly important type of additives generally used in molding sand. Okay, look, there you can write coal dust, sawdust, coming out of the wood while shaping the wood. Okay, sawdust, or wood floor, starch, dextrine also you can say. Okay, and there are also iron oxide or silica floor also. So these things you must keep in mind, they are very important for your competitive purposes as well. Okay, so these are the additives you must take a note. These are the additives we are going to use during preparation of molding sand. Okay, now coming to the look, what are the functions of additives? I can say you this generally helps in the enhancement of bench life and resistance to drying out, and also they gives generally hot strength development, surface finish also, collapsibility and resistance to expansion defects. There are many functions as well. Okay, so these are the additives. Okay, now mainly coal dust is very important. You must take a note for coal dust especially. I will tell, for coal dust we are going to have better surface finish. That is very important. You must take a note. Okay, better surface finish. And for sawdust, generally you can find this type of questions in different competitive examinations. They are asking you why we are adding coal dust or sawdust. Sawdust and coal dust are very important. Okay, the function of sawdust and coal dust. Okay, this sawdust you must take a note. we are having for proper green strength or higher green strength, you can write. Okay, so these two additives are generally very important and asked by many of the competitive examinations. For coal dust we are having better surface finish, you must take a note, and for sawdust we are having great green strength or good green strength. Okay, it reduces the expansion defects as well while improving the flowability of the, you can also write flowability. Okay, so flowability is also provided by sawdust, adding sawdust. Okay, so flowability of the molding sand and helps maintain uniform mold density. Okay, and that is all we can say. Okay, now there are also starch and dextrin. I must tell you that generally starch and dextrin are used for expansion, to remove the expansion defects such as scab as well. Okay, now the iron oxide, you can write, take a note, iron oxide is also very important. For iron oxide we are having improved surface finish as well, so surface finish you can write as well. Okay, collapsibility also gives collapsibility as a green strength and as well. You must keep in mind always, coal dust is for better surface finish and sawdust is for great green strength. That is a very important thing. One last thing I must tell you before ending this video session, that is a binders. I already mentioned we are adding binders as well as additives to the molding sand beside the clay, sand and moisture. So binder is also very important, and it provides strength to the molding sand. Okay, now the commonly used binders are generally linseed oil, core oils, resins, dextrin for both purposes, additives also. Okay, molasses. Okay, now core oils are a mixture of linseed, soya, fish and petroleum oils and coal tar. Okay, so this binders plays a vital role also in molding sand as well. So you must have some name in your memory, as they will be asking you MCQs on these binders in many of the competitive examinations as well as semester examinations as well. So that's all I think for this particular video session of today. Hope you all have enjoyed, and if you are having any queries or doubts, you can comment me in the comment section. And if you have liked today's video session, please give me a like and share it with your friends. Stay happy and thank you for watching.